least we believe that to be the case.
Well, like if we look at, yeah, like for example, if we look at that junk DNA, right, that you were, because now we're seeing that, you know, in that non-coding DNA, it contains sequences that act as regulatory elements, right? So that means they determine when and where genes are, say, turned on and off. And also those elements provide sites for obviously specialized proteins. I think those are called transcription factors. So they'll bind, and then from there they'll either activate or repress the process by, say, which the information from genes is turned into proteins. So would you agree that those are pretty important functions?
I would say they have function, but technically speaking, they're not functional.
Okay, so what I just said to you, you don't believe that that's functional, because in those non-protein coding regions, we see those regulatory functions. That's not function to you?
So the reason I wouldn't consider it functional is that what's functional in an organism is the proteins and the various structures that are made as a result of synthesis of proteins. If you don't have something being synthesized, right? I mean, sure, you have regulatory elements, that's fine. But these regulatory elements don't do anything on their own. They're acting as a way to guide polymerases and transcriptases to monitor the activity of these genes, which that's perfectly fine. But it still doesn't transcribe a gene. It doesn't.
Now, do you think you're okay? Now, do you think you're putting a little bit of an evolutionary bias into that assessment? Because if these regions of non-coding DNA do provide instructions, say for the formation, which we just agreed, for the formation of certain kinds of, you know, RNA molecules, like for even CRISPR and I were talking about how, you know, non-coding DNA includes, and he admitted that this was actually functional, it includes transfer RNAs, right? And even ribosomal RNAs. And what does that do? That helps assemble protein building blocks, which is amino acids.
Sure. Yeah, I don't think anybody denies that RNAs are significant. I mean, the thing is that, you know, one gene can create several hundred different products, and that's mainly because of RNAs.
Okay, so obviously it's not idle then. So these non-protein coding regions are doing something. They're not idle. So in our model, that's consistent. And based on the fact that we know very little about the DNA code and the functions, because we're accidentally coming across various functions. So imagine we actually, say, did these gene knockout tests. We're only going to, obviously the trajectory is strong, say for genome-wide function. And I think based on your assessment, I think that's more of an evolutionary bias, because to me, and I think to the majority of people, I mean, these are important functions, and any type of mutation on a gene that has a regulatory function will be deleterious. Go ahead.
Like I said earlier, I mean, I'm not denying the fact that it's not important, but if you're talking about function particularly, that doesn't matter, because you're talking specifically whether or not a portion of DNA is coding for some kind of product, which ultimately is a discussion that takes its roots in biochemistry. The really simple aspect of it is that, look, you know, sure, there are things that are, you know, that allow for polymerases to activate and to create a product. That's, you know, sure, it acts as a regulatory sequence. It helps guide RNAs into place. But in the same sense, though, it's also not coding for anything. So to some extent, it's functional, but not strictly within a biochemical setting.
I think, well, for one, I would just disagree and say that, you know, everything that I've been saying and we're agreeing on, I would say that that is functional. I would say that a mutation on a gene like that would, you know, create a problem for the organism. As it would be like a ripple effect, right? But I think it all comes down to models, right? So for evolutionists, the ultimate, and correct me if I'm wrong, the ultimate cause of genetic change is mutation, right? Like if you look at these nuclear DNA differences and these mitochondrial DNA differences, you would conclude those are based on mutations, correct?
Well, part of it's mutation, but that's not the most important aspect of it.
Okay, now for us though, and I'm sure you understand, like what would our, like for example, pre-existing heterozygosity, like I understand you don't agree with it, but what do we mean by that when we say that?
That there are genes that exist on, you know, different chromosomes that we replicate via, that we can't replicate on our own, that we require the use of another human being to replicate?
Okay, yeah. So like millions of differences, say in the DNA sequences of chromosome pairs. We're saying that was built into organisms from the beginning by the creator. Okay, so when we look at the origin of species, we're saying that long periods of time is not required for the new species, because if we start with these heterozygous organisms, the visible distinctiveness and change in offspring, it's going to be fast. So if you look at things like recombination, gene conversion, that would provide many new varieties of, say, combinations of traits quickly, because we're saying these differences are already built in. So if we go back to functional versus non-functional, non-protein coding regions, we predict that they're not going to be idle. They're going to have function, because if we're saying that these tens of millions of nuclear DNA differences were built in, if they're design variation, we'd expect them to have action. Okay, so obviously ENCODE revealed that 80% is transcripted, and now we're seeing more function. Like, for example, pseudogenes, which we thought were false genes, actually show function, or something like protein moonlighting. We're seeing these proteins that have multiple function. That's consistent with us, because that's a prediction, a testable, falsifiable prediction based on pre-existing heterozygosity. But you're saying, obviously, these are not true functions, or it's spurious transcription. To me, that's a rescue device. How do you feel about that?
So it comes down to how you view something as functional. I mean, if you're considering the fact that one gene is transcribed in the course of, 8,000 runs as being functional, sure, that isn't really a valuable definition of functional, because it means that at best, that, okay, there's a gene transcribed, but it's far from being transcribed regularly. There's some genes that are transcribed, 30, 40 times within an hour, let alone 30, 40 times within however long the duration of the experiment is.
So